Okay, so just a quick walkthrough of these flight sim panels I built a while ago. So these are 3D printed enclosures, and these are just buttons and switches and knobs from the hardware store, and LEDs and LCD here. So one of the biggest drivers of this design was that it had to fit in a small space, and my desk isn't tiny, but I just don't want to have to stow and then unpack these panels every time I want to fly. So here, whether I'm working or I'm simming. So another thing I found with commercial products is they often tend to be very specific to the type of airplane. So there's really high quality, really good looking Airbus panels, Boeing panels, and general aviation panels. But I went for generic, they're not specific to any airplane. That was one of the design principles. The other thing was that I didn't try to be realistic, largely because I just don't have the skills or craftsmanship required to build something like that. So I went for just simple, practical. So this faceplate here is just held on to the enclosure by 4 M3 screws, and they're screwed into heatset inserts. So there's not much to it. You pull out the panel and then you can see the internals, but I won't do that right now because some of the connections, I think, from this first version are still a bit flaky, and every time I open it, I'm a little bit paranoid I might break some connections. So I would prefer not to open the box unless I have to. Quick look through the back here. You can see the tangle of wires. I tried to clean it up with zip ties and everything, but there's a heap of hot glue, and yeah, it looks pretty bad. The other thing was that it had to be fairly ergonomic to use. So I think the spacing between these switches is actually okay for me. And so I had a problem where the whole box would move when I would press a button or flick the switch. So the solution is not very sophisticated. So it's just Velcro. As you can see, it's just held to the desk with Velcro. So if I want to move it, I still can. But the box is not going to flop around when I flip the switches. So these switches, these are just SPST switches. For simplicity, I didn't want to mess around with other types of switches. And basically, these work pretty well. So a bit of thought did go into the configuration of these toggle switches and dials. This rotary encoder here actually toggles the master lighting in the 777. So it's just one dial for everything. And this one is for the MCP. And it's a similar idea with these switches. So with the landing light, toggle it, it toggles all 3 landing lights. And the taxi light actually toggles the taxi light and the runway turn-off lights. But just for simplicity. Strobe lights just toggle strobe. Beacon light actually toggles the beacon, nav, and logo lights. So I thought that was an acceptable simplification. And seatbelt, well, seatbelts. APU, so the APU switch on the actual Boeing, it's a switch like this, but the mapping works. So if it's up, it's off. If I push it down, then it starts and goes back to the on position. And then when I want off, just switch it off. So not realistic, but it works. And this is pretty much it. Is there anything I would do differently if I were to make the panels again? Yeah, probably. For starters, modeling this in Autodesk Fusion, I was actually completely new to Fusion, so I didn't know anything about parametric design. So my models ended up being not parametric, and it was really difficult to change dimensions or whatever as I progressed the design. So definitely in the future, I will make the designs parametric. Otherwise, that was the main thing. Oh yeah, and the Arduino I'm using is an Arduino Uno, which has quite a limited number of pins. I don't think it's a big issue because it kind of constrains the design. Like I didn't want to go crazy building a panel with like 30 or 50 switches. And it didn't really suit at the time anyway. So yeah, I think that's about it. Please feel welcome to comment below.